Alright, so in this video I'm going to go over the review for the circles unit. Hopefully at this point, if you weren't in class, hopefully you've at least taken some time to look at these questions and see if you could figure them out on your own. If not, you can try and pause kind of as I'm explaining the questions and see if you can kind of do it on your own. That's going to be the best way that you can practice for this. So for the first question here, it says the measure of arc AB is 120 degrees as shown below. So this arc here is 120 degrees. Find the measures of the angles in triangle ABC. Okay, so if you think about lesson 2, where we learned about inscribed angles, all 3 of these angles making up the triangle are going to be inscribed angles. So if we start with, we could really start with either C or we could start with B. Let's start with C. So angle C here, this angle is defining this 120 degree arc. So because this angle defines this arc, this inscribed angle is going to be half the measure of the arc that it defines. So this is going to be 60 degrees because 120 divided by 2 is 60. And then if we look at angle B here, angle B is defining this arc, which since AC is a diameter, then we know that this arc is going to be 180 degrees. So if this arc is 180 degrees, this inscribed angle is going to be 90 degrees. And then if we think about 180 degrees in a triangle, we have 90, 60, this is going to have to be 30. To add up to 180. So that's that question. Number 2, which of the following is true about the circumcenter of a triangle? In the example picture, D is the circumcenter. Select all that apply. So the circumcenter, this question is getting at what's the difference between the incenter and the circumcenter. So let's look at our options. It is the intersection point of the 3 angle bisectors of the triangle. Okay, that's not going to be right because that's incenter. It is the intersection point of the 3 perpendicular bisectors of the sides of the triangle. That is true. It is the same distance from all 3 vertices or points of the triangle. That is true. It is the same distance from all 3 sides of the triangle. Nope, that's incenter. Number 3. A circle has a circumference of 40 pi centimeters. Find the area of a sector within this circle with a central angle of 45 degrees. Express your answer exactly in terms of pi and as a decimal rounded to the nearest whole number, and include units in your answer. So if we want to find the area of a sector, and we know the circumference is 40 pi centimeters. So if we want to find the area of a sector with a central angle of 45 degrees, we're going to want to use that formula pi r squared times theta over 360. But it doesn't explicitly give us what the radius is. So what we can do is, since the circumference, we know that circumference comes from 2 pi r. So we can actually use our circumference to find our radius. Divide by pi, they just cancel out. Divide by 2, r is going to be 20 centimeters. So then we can plug in pi times 20 squared times theta over 360. Oh, and this should be 40. I'll just make that a little 0 there. Oh, nope, 45 over 360. So then we just have to do that calculation. If we want to leave it in terms of pi, remember we can just leave pi out of our calculator unless you're going to do the calculations by hand. So if I'm going to do, I don't know if you can see that very well, but we're going to do 20 squared times 45 over 360 That gives me 50, so that means I'm going to have 50 pi for in terms of pi. And don't forget units, so square centimeters. And then if I just figure out what 50 pi is, so 50 times pi gives me about 157, rounded to the nearest whole number, square centimeters. All right, so if you need your radius, it doesn't give you your radius, but it gives you your circumference. You should be able to find your radius from your circumference. Okay, next question. A circle has a radius of 8 centimeters. An arc within this circle has a length of 6 centimeters. What is the measure of the central angle in radians that defines this arc? Express your answer in simplest form. Okay, so first of all, if you think back to lesson 11, when we first started talking about radians, we said our angle in radians is equal to our arc length over our radius. Arc length over radius. So if we're trying to find our angle measure in radians, we have our arc length, we have our radius. We can just take our arc length divided by our radius and we're done. So it's going to be 6 centimeters divided by 8 centimeters. Theta is going to be 6 over 8. If we simplify that by dividing top and bottom by 2, just simplify the fraction, that gives us 3 over 4 radians. All right, and that only works for finding your angle in radians, not for degrees. Although you could hypothetically do that and then convert to degrees if the question asks for degrees. Which brings us to this. So converting between degrees and radians. So remember there's 2 pi radians in 360 degrees. So 2 pi radians is the same angle as 360 degrees. So if we think about that, kind of what we talked about in class was if we know 360 degrees is the same as 2 pi radians, then 180 degrees, which is half of the circle, is going to be the same as pi radians. And that's going to be useful. So if we're converting between radians and degrees, so let's look at this pi over 6. So we can take our pi over 6. And one thing you can do, just as like a trick that some people have realized works, just replace the pi with the 180, because basically what you're doing when you're converting, you can multiply by 180 over pi. If you do that, your pi's are going to cancel out, and you're essentially just doing 180 over 6. And then if we do 180 over 6, that gives me 30, so I'm at 30 degrees. So another way to think about that is basically what we did here was I took pi over 6. One way to think about it is I divided it by 2 pi to figure out that's 1/12 of the circle. And then if I multiply that by 360, 1/12 times 360 is 30. So I'm figuring out that pi over 6 is 1/12 of the circle, and then 1/12 of 360 degrees is 30. So that's going to be my degree measure. Going the other way, if we do this like what we did here, our 45 degrees, we can multiply by pi over 180. So in other words, divide by 180 and multiply by pi. And if we want to leave it in terms of pi, just leave the pi out of the calculation in your calculator. 45 over 180 is 0.25. If I want to convert that to a fraction, on this calculator, I can go second and then this button right here. That gives me 1/4. So it's 1/4 pi, which we can just say is pi over 4. And then pi over 2. One way to think about this is, well, if pi is 180, then pi over 2 is going to be 90. It's just halving. 2 radians. I put this one here just so that you realize that radian measures don't have to have pi in them as they're written. Because remember, pi is just a number. So this just means 3.14-ish over 2, which is a little more than 1.5. So this is like a little more than 1.5 radians, 2 radians. So it doesn't have to have the pi written in there. So still do the same thing. We can say 2 times, like we did here, we were converting to degrees. So we did times 180 over pi. So for this one, we'll just leave, we'll put the pi in the calculation. So we get 114.6, I'll say. (120 degrees) is going to be, I'm just going to kind of put the answers here now. So 120 degrees is going to be 2 pi over 3. If you think about, if you know that pi over 3 is 60, which isn't in this chart, but we talked about it in class. If you know that pi over 3 is 60 degrees, 2 pi over 3 is twice that, so 120. And then 4 pi over 3, let's do that calculation quick. So we're going to have 4 pi over 3, we want to multiply by 180 over pi. So essentially what we're going to end up with is 4 times 180 over 3. Let's do that calculation in here. We get 240. All right. Number 6. Lines x, y, and y, z are tangent to the circle with center W. Find the missing angle measures in quadrilateral WXYZ and explain how you reached your answers. All right, so in lesson 3, we talked about how if we have a tangent line, and then we have a radius drawn to the point of tangency of that tangent line, then those have to be perpendicular. So a tangent line is always perpendicular to the radius drawn to the point of tangency. We wrote that down on our reference chart. So we know that these have to be right angles. So we can say angle WXY and angle WZY are formed by tangent lines and radii drawn to their respective points of tangency. So they both measure 90 degrees. And then once we know that these are 90 degrees, 90, 90, 70, we need the whole quadrilateral to add up to 360 because a quadrilateral always adds up to 360. So 90, 90 is 180. 70 gives us, here. So we're going to be left with 110 degrees, and that's going to be W. So angle, we'll call that ZWX measures 110 degrees. All right, next problem. A circle has radius 15 inches. An arc within that circle has a length of 3 pi inches. Find the measure of the central angle to find the arc. Express your answer in degrees. Okay, so we know that arc length can be expressed as 2 pi r times theta over 360. R is the radius, theta here is our central angle. So if we know the arc length, we know the radius, then that gives us enough information that we can solve for theta. And you can kind of go in any order with this because it's all multiplication and division that we're going to have to do to get theta by itself. So you can kind of do any order, but I'll start by multiplying by 360 just so we get that fraction out of there. So I'm gonna leave it in terms of pi for now. 360 times 3 is gonna be 1080 pi. Okay, so far all we did was we got rid of that divide by 360. I'm also going to, well, first of all, I'm gonna simplify this to 30 pi times theta. And if you want to, we can divide by 30 pi altogether, or you can divide by 30 and divide by pi separately. It'll do the same thing. Just be careful if you are going to divide by 30 pi, make sure to put parentheses there. So if I take, so you might just see, okay, these are going to cancel out. If you don't see that, if you're going to do 1080 pi, get this where you can see it. 1080 pi divided by, you want to put parentheses here, otherwise it's going to think that you're dividing by 30 and then multiplying by pi again. So 36, and you could have gotten that by just doing 1080 divided by 30. 36 is theta, and then that's it. So theta is 36 degrees. All right, and then find the value of x. Okay, so this is a cyclic quadrilateral. So we talked about these in lesson 4. I know it's a cyclic quadrilateral because by definition, a cyclic quadrilateral is a quadrilateral that you can draw a circle through all 4 vertices, and this is showing the circle drawn through all 4 vertices. So I know this is a cyclic quadrilateral. I know that opposite angles are going to add to 180 because it's a cyclic quadrilateral. 180 degrees. So I know that these two angles, these are opposite angles, they should add to 180 degrees. So I know that 4x plus 124 is going to have to equal 180. So then, and you could think of this as an equation like this from the start, or you could just think, okay, if these have to add to 180, then this angle has to be 180 minus 124 is going to give me, let's see, 56, right? So then I'm just going to make sure I'm right. I'm not going to trust my mental math right now. Okay, 56. And then all we have to do is to solve for x. So we know that this angle is going to be 56 degrees, but that's not what we're trying to find. We're trying to find what's x. So we know that 4x is 56. So then x, we can divide by 4 to get x by itself. This is just regular algebra. So 56 divided by 4 is going to give me 14. And that's it. I guess technically it would be 14 degrees. All right, and that's it.